converters, non-isolated converters, okay? Which is this one is buck boost converters. Okay, so as you can see, only the location or the position of the switch, the diode and the inductor are changed, okay? The other components such as the capacitors, the load, and the voltage source is remain at the same position, okay? So buck boost converters, so as reflected by its name, so it can step down or step up the output voltage depending on the values of duty cycle. Okay, so I hope you already know duty cycle is the ratio between T on over T. Okay, so the relationship between V out and V input is actually equals to V out is equals to negative D1 minus D V source, okay, or V input. Okay, so this is the input and output relationship of the buck boost converters. So how can we derive this relationship? Is actually by analyzing the steady state during on state and also off state. So we first go for the analysis of when the switch is on or the switch is closed. Okay, ini on sama lah on So what happened when the switch is actually at position here. So the switch is on or closed. Okay. So based on the circuit's operation, this diode will automatically reverse bias. Okay. So the output is disconnected from the input. And the analysis will be concentrating on VL. What is your VL values when the switch is closed? So based on this circuit, the current will only flow through this circuit. So meaning that your voltage source is actually charging the inductors. We know that the charge of the inductors is proportional with the current inside. So it's actually proportional with the current of the inductor. So when it is charging, meaning that the current is actually positive, in positive direction, meaning that it increase from I min to I max. Because actually the energy, okay, inside the inductor, you can actually derive like this, 1 over 2 Li square. This is the energy inside the inductor. Okay. So since why we actually look at the current, because actually at this state when the switch is on, okay, the inductor is in charging mode. Okay, and charging mode meaning that the energy is actually increasing. We store the energy. So when this energy is increasing, mean that where the L is constant, 1 over 2 is also constant, meaning that the energy is proportional. Can we say that it's proportional with I square? So meaning that if the energy is charging, so the current is actually also increased. So that's why we see that the current is increased. Okay. So our focus is on to obtain the VL. So right now your VL is equals to VS, and we already know that VL is L di over dt, right? So the same procedures. We know that di over dt is actually the change of I over the change of t, right? So this one is IL during on state over delta T during on state is actually D. Okay, so that's why you can actually tak nampak nampak over there nampak clear because dia punya slide ke bawah sini. Macam mana nak buat? Tak boleh nak buat apa? Macam mana nak ni If I... Oh. Kalau macam ni macam okey sikit Macam tak nampak pula. Saya tak nampak. Discard. Okay. Ni lagi ke bawah. Duplicate lah. Think much more better kot than this one. Okay. So finally, the delta RL on is actually VS over L multiplied with T on, which is DT. Alright, this is the important relationship that we will derive from the switch close. Yang ni pun ingat. This is why you need to remember. Ataupun don't memorize lah. You need to just how to derive it. Okay, clear Any problem? So this is IL during on state. So it increased from Imin to Imax. And this is the VL waveform during on state. So yang ni semua is actually on state So VL is equals to VS. Okay, positive VS. Because from here you can see it. Okay. And this is the ID current, I diode. So as you can see, this is your diode. Right now your diode is actually in reverse bias. So there is no current. So ID here is 0. So that's why you have 0. Okay, 0 current. Okay. So let's look at when the switch is off. What happened when the switch is off? So when the switch is off, okay, the inductor here will actually discharge. So the current will flow here and then it will force the diode. Okay, so it will force the diode to turn on because it need to discharge the energy. Banyak betul gangguan. Ni gangguan makhluk halus ke apa? Oh dah, lagi dahsyat. Oh, ini komputer ke projektor ni? Hold on Okay, so the inductor is will actually discharge. So the current will flow here, discharging. So as you can see, the current is actually moving from Imax, go down to its minimum values. So since it is discharging, so it need to have a flow. So the diode is actually must be turned on, okay, forward bias. So, and then we need to analyze what is the voltage across the inductors. So the voltage across the inductor right now, as you can see, this is the node here, which is the same node of this one, V out. So meaning that this one is also V out. We consider there is no voltage drop across the diode. So this one V out, so meaning that this one is also V out. So that's why we can write down the voltage across the inductor during on state is equal to V out. Okay, and then we know that the inductor is L diL over dt. Then the same process, finally you will obtain that the delta IL during off state over delta T, which is T off, 1 minus dt must equals to this one V out over L 1 minus dt. Okay. Oh, sorry. This one. Okay. Okay. So finally, we will have this equation and we need to use this. Okay. Delta IL during on plus delta IL during off must equal to 0. Okay. So you will obtain this equation. Okay. V out is equal to negative Vs d over 1 minus d. Since the name is buck boost converters, so it depends on the duty cycle values. So if the duty cycle is less than 0.5, so it will become buck converters. When the duty cycle is larger than 0.5, so it will be boost converters. Okay. When D is 0.5, what happened when D is equal to 0.5? Buck boost. When D is larger than 0.5, so it will become boost converters. When it is lower than 0.5, it will become buck converters. What happened when the duty cycle is 0.5? Buck boost juga? Ideal. Apa tu ideal? So V out is equals to V input ataupun Vs lah. So same. The unity is actually, the gain is actually 1. Okay. You substitute D is equal to 0.5 here. 0.5 and then this is also 0.5. You will obtain that this is 1. Right? So when D is equal to 0.5, so it will neither be boost or buck. Okay. And there is some important notes here. The second one, which is the source. If you see or analyze this circuit, the source will never connected directly to the load. Okay. If you notice that during off state, okay, during off state, as you can see, the source is not connected directly to the load, right? This is the load, this is the source. It's disconnected. This is when the switch is open. What happened when the switch is closed? Same. Where as you can see, the voltage source is not directly connected to V out. So meaning that it is transferred using inductors. For buck converters and boost converter, there are states where the voltage source is directly connected to the load, either on or off state, for buck and boost. But for buck boost converters, okay, for both state, the source will never directly connected to the load. Okay, so that is one important features. Balik. Meaning that sorry dia start balik lah. Ada saka ke? Ada orang yang bawa saka ke? Ada orang sabotage ni. Okay, so answering your friend's question. So what is the benefit of not connecting directly? So the benefit is in terms of the safety. Safety. Okay, because sometimes we know that there must be some overshoot or sorry, short circuit at the load side. So if your source is not directly connected, then your source will be in the safe side. Boleh tengok dia nak main-main lagi tak? So actually for the buck boost converters, the main key player is the inductors in this buck boost. So actually the analysis for the IL I think is actually the same. Okay. To get the IL, usually to get the IL this one, so the analysis is actually to get the IL average. Okay. And to get the IL max. And also what next? IL minimum. Okay. And then to determine the L minimum for CCM, you need to set I min equal to 0. Right? So this is actually for the IL analysis. You need to find the IL average, IL minimum, IL max, and to determine the CCM, you need to have L minimum. Okay. So how to find the minimum inductor? Set I minimum equal to 0. After you obtain L minimum, then the L actual that you use should be usually larger or equals to 10 times of L minimum. Because L minimum is the minimum value, right? For the converters to be in CCM. So memang kita ambil yang lebih tinggi lah. We need to choose higher values. Understand? Okay. So Imax equation is still the same, which is IL average plus delta IL over 2. And for the I minimum is also same, which is delta IL average minus delta IL over. Okay. So how to obtain IL average? This one. By using this P in and P out relationship. Okay. So P in is actually Vs Is equals to V out square over R. Okay. So right now we want to see what is the relationship between Is and IL average. Apa dia? Is is equals to what? We can see that during on state, this is your Is, right? Is is equal to IL. But when the switch is off, Is is 0. So meaning that we can say that your Is is only equals to when the switch is on. So we can say that Is is equal to DIL. Right? Because Is is only equal to IL when switch on. So we can say that the relationship between I source and IL is I source is equals to DIL. Okay, here. So from that, you can calculate your IL average. Okay. Itu bunyi ni Hah? Bunyi aircon ke bunyi LCD? The noise come from LCD ke aircon? Bahaya juga tu. The apa tu? Dia punya the tu macam nak jatuh tu. Dia punya apa? Investor apa dia punya? Either one, gitulah dua. Sometimes we fall. Okay. Yeah, ni I think I can skip this one. So and then to get the ripple voltage, usually we will actually go for the IC. So as you can see, the waveform of the IC is similar with the boost converters. Okay. So this one is your IL Betul ke? This one is your I out. Okay. I out. Okay. This one is your I out, which is you can calculate by using V out over R. This one is your DT. Okay. This one is actually your Q. Okay. So, and then using this simple equation, same for both converters. I repeatedly say again, Q is equal to CV. You can memorize the equation, but if you, for example, maybe got blurry during the exam, you just memorize this one. So from that you can get the answer, or you can actually get the equations. Okay, and then from that you can calculate your capacitor values based on the output voltage ripple. So I want to highlight this one we have for output voltage ripple, we have this one. This one is output voltage ripple. Okay, the unit is in voltage. And we have another one which is R, which is ripple factors. So ripple factor is delta V out over V out. This is just a ratio. Okay, so please be noted on this. We have, sometimes we give you two information. Sometimes we give you output voltage. Sometimes we give you ripple factors. So I hope you know what is the ripple factor R and what is the output voltage. So ripple factor is actually a ratio. There is no units. Okay. Okay, the output voltage usually it will give you in percentage. For example, 0.05%. So this one usually will give you the ripple factor, the ripple voltage, which is 1 volt. 1 volt meaning that the voltage here, for example, is 20 volt. You have a ripple voltage of 1 volt, meaning that this min and max is actually 1 volt. Okay. So it's okay. We go for what I call some examples. Okay. Understand? Laju je saya buat 30 minutes. Okay, we go for one example that I have already shared with you in the WhatsApp group on the buck boost converters example. Okay, saya pun nak kena download dulu. Okay, so buck boost converters. Okay, buck boost converter example. I don't remember where I got these examples, but I think this one is very good. Macam mana saya nak ni Okay, so this is the question. The style of this question is somehow quite different, okay, from the maybe a typical question. If you can understand this, then you can understand this question. Then I think your understand the comprehension of your knowledge on these buck boost converters is good. Okay, if you can understand this one. So buck boost converters of figures 6.11. Berapa figures? Okay, so I draw for you. So this one, and then you have cap inductors, the diode. Okay. Okay. So the input is 24 volts. Pak. The input 24 volt and the output is, the polarity is like this, but the output is negative 36 volt. Okay. And the resistor is 10 ohm. The switching frequency is set at 100 kilohertz. Berapa pula dia punya ni? Oh, dia tak bagi value something. Oh, tak bagi langsung. Okay, tak apa. It didn't give you any values. Inductors, capacitor values, and so on. So it's only give you the resistance. And then this is your switch on and off. So if the switching is set 100 kilohertz, determine the inductance. Oh, memang lah. So it want you to find what is the suitable inductance values. And then what is the suitable capacitor value. The information given here is the minimum current. Minimum inductor current is 40% of the average values. So as you can see how tough it is. So I think I give you maybe 1 or 2 minutes to understand this one. How to solve this. You don't need to memorize, just use the common equations that I have already explained. But the things you need to know lah, this one, this is very important lah. D is equals to 1 minus D V source. And then IL average, what is the equation? IL max, which is IL average plus delta IL over 2, and IL mean, IL average minus delta IL over 2. So find first what is the, you can find what is delta IL. Please find delta IL. Boleh tak dapat kan? What is your delta IL? After you obtain delta IL, what is your IL average? Dapatkan delta IL. What is your delta IL? Boleh dapat? Can you oh, okay. Dapat tak? Tak ataupun you tahu nak buat tapi tahu nak buat ataupun tak tahu tu. How to obtain data IL? Okay, so if you obtain, for example, if you start with delta IL kan, we know that delta IL is from the circuit. For example, delta IL on. I use delta IL on because delta IL off and on is actually same kan. So I use delta IL on when the switch is on. Okay, when the switch is on, so I can just put is equal to VSL dt. But the problem is I don't know the L. Okay, the duty cycle can be computed, right? Berapa duty cycle? 0.6. Okay, you can compute by using this equation, right? But the problem is we don't know L. The T is also given, which is 1 over 100K. So what are the, so right now, meaning that we cannot use delta IL to start with. Apa? What is the information? The information that we can use this one. The minimum current IL mean is 40% from the each inductor current average. What it mean that is the only information. IL mean is 0.4 IL average. Sorry? This one. Determine the inductor or the inductance value such that the minimum current usually meaning referring to the IL mean. Okay, is 40% from the average load, from the average, usually this one, if referring average, is actually referring to the average inductor current. Okay, so meaning that we can write down that sentence in mathematical equation, IL mean is equal to 0.4 IL average. So what is your IL average? From P in, P out. P in is Vs Is is equal to V out over R. And Vs, we already know, is actually equals to DIL average. So multiply with Vs. V out over R. V out is apa? 30, negative 36. Okay. So, but this one, we usually, this one positive, right? So we only get, we ignore the sign. Okay. And then duty cycle is 0.6. Okay. And Vs is berapa? Vs is 34. So from that, you can calculate your IL average lah. 36 over berapa? Oh, ada R ni, ada R. Multiply with resistance values 10 ohm. Boleh follow 0.25. Boleh, betul lah. we use this information because we given 36 and Vs is 24. From that, you can calculate your D. Okay. So your I average is 0.25. So your I mean apa? So maknanya your IL mean is 0.4 multiplied with 0.25. 0.1. So your I mean is 0.1. Okay. Terbaik. Saja je. Okay. Kuasa 2, kuasa 2. Forgot to bring. So 36 kuasa 2. Thank you. So 9 lah, 9 amps. Tengah-tengah hari ni kan. It's better to do exercise. So 0.4 over 9 amps is 8.6. 3.6. Oh, 3.6 eh. 3.6 amperes. I at average. So what's next? I mean dah dapat. We have obtained I mean. And we know that I mean is what? No. Yeah, 40%. So right now we have already obtained 3.6. Our main question is to obtain the inductor. So right now we have already calculate I mean. So what's next? What is the equation? I mean is the 3.6. Okay, so meaning that from that, okay. Okay. We know that IL mean, which is 3.6, is IL average minus, right? And this IL average is 9, right? So from that, you can obtain berapa? 9 minus 3.6, 5.4. So 5.4 is equals to delta IL over 2. So this one 5.4 kali 2, 10.8. So 10.8 is equals to delta IL. Okay. You can use delta IL on or delta IL off. So I use delta IL on, which is delta IL on is equals to Vs over L dt. So right now your Vs is given berapa? 24. Your D is also you have calculated already 0.6 multiply with T is 100 K. Okay, so from that you can calculate your L. So this is not L minimum, okay? This is not L minimum. This is your L that give you 0.4% of IL average. You need to, that's why in the slides, all our analysis is to obtain the L minimum, right? But this question is not about L minimum. This is about the inductor value that give you I minimum equal to 0.4 of your IL average. Okay? Itu berapa? Okay. 24 bagi 10.8 kali 0.6 Berapa? 13.33. 13.3 microhenry. Okay. Faham Yang L ni bukan L minimum tau. I hope you can differentiate between L minimum dan L. Yang this question is referring to the L that give you 0.4 I mean. From this, actually, if you are being asked to draw what is your IL, for example, what is your IL? From here, your IL average is 9. So you put here 9 amperes. So this is the average values. Okay, and it will ramp from I minimum, which is the value that you have calculated is berapa tadi? 3.6. This is your I minimum. And then it will ramp to some maximum values. And then ramp down again to its minimum value again. Okay. This one, from here to here is your delta IL, which is berapa 10.8 amperes. Which means that I max here is berapa? 10.8 is 5.4. 9 plus 14.4 amperes. Kan? Sebab this one is 5.4. This one also 5.4. Betul tak? Kan? Delta IL over 2 is 5.4. Delta IL multiply. So 10.8. So I mean 3.6. I max is 9 plus 5.4, 14.4. Sorry? 9? No. 5.4. Here. We have calculated it. 3.6 is I mean. Here. Delta IL. This one is delta IL over 2. Multiply with 2, so we have delta IL. From min to max. Okay. Betul ke sama dengan solusi saya bagi? Sama. Nasib baik sama. Tapi dia L dia 13.3 betul lah. Okay. So right now I hope you clear the most important thing is actually yang the waveform lah. I hope you know the relationship what is the IL over 2, what is IL, what is delta IL, what is IL average, the relationship. Okay? Okay, next is on the ripple voltage. Oh, dia main-main lagi. Okay. This one tak payah salin lah sebab because saya pun I have already share you the solution lah. So, macam nak padam ni? Banyak lah tu. After this, we will go briefly on the isolated converters, which is the flyback, forward and so on. But just a brief lah. Bukan yang tu tak masuk final exam. Okay, determine the capacitance required to limit the output voltage ripple. Okay, this one. This is very good also. You see, the information. Determine the capacitance required to limit the output voltage ripple to 0.5%. So don't be fool with this information, output voltage ripple, but give you 0.5%. So meaning that this one is actually ripple factors. This one is actually ripple factors. 0.5% meaning that this one is 0.005, 0.005, which is this one is actually delta V out over V out. So from here we know that your V out is we use 36 dia punya modulus we use yang dia punya, we ignore the polarity. So V out is 36. So from that you can calculate your delta V out. So 0.005 multiplied with 36 berapa? 0.18. Meaning that if you draw your V out, you will have an average V out 36, but you have a ripple maximum minimum voltage, which is this one we call delta V out, which is 0.18, meaning that it has a maximum values of 36.18 and minimum values of 36 minus 0.18. 35.82. Okay, I hope you understand this. Okay, the average is 36, but it can fluctuate maximum to minimum values because you have a ripple voltage here. Okay, for DC-DC converters, the best DC-DC converters is where your output voltage or your ripple factor is as minimum as possible. 0.01, 0. Because when you have this ripple, actually you will actually your product will be broken lah, memang rosak. Sebab actually this one adalah is actually related to the power quality. Okay, for a DC system, the power quality, the voltage must be pure DC voltage, pure DC current. If you have pure DC current and pure DC voltage, then your power quality is very good. But if you have a DC but you have some ripple, then meaning that your power quality is not very good. So it will broken your equipment, DC equipment. Okay. But to have this ripple to be very minimum, your capacitor value must be very, very big. Usually very big capacitor will resulting your ripple voltage very, very small. Kan? Because yang ni lah. Yang Q is equal to C V kan. Kalau ada perubahan kat sini. Okay. So if you want, for example, this one C over delta Q. So if you want to reduce this one, so meaning you need to increase the capacitor. Silap. Betul lah. Salah. Mana? Betul ke? Delta V. Okay, Q. Macam mana ni? Delta Q over C. Okay, sama ada okay. Mana you increase lah. This one. Okay. So 0.005. Okay, padam ni one. Okay, so same. The current IC, IC, this one, okay, for the buck boost is actually same with the boost converters. So this one is your V out over R. Okay, usually kalau IC, memang you punya this one, yang bawah ni, is equal to I out. This one must equals to I out, which is V out over R. Because IC is related to I out kan. Kita ada this one saja. Okay. I out. Yang ni IC kan. So ada relationship lah. So this one is V out and this one is your DT, T on. Okay. So dapatkan keluasan this region lah, which is your Q. Okay. So your Q is equals to V out over R multiply with DT. So V out is given 36 over 10 multiply with duty cycle 0.6 multiply with 1 over 100K. So berapa eh? To 21.6. 21.6 micro column Micro column. And then from that Q is equals to C delta V Okay. And then your C is equals to Q over delta V. Your Q is 21.6 micro column. Over your delta V out is already calculated 0.18. Nampak? Betapa senangnya. Tak ada pun nak kena ingat-ingat you punya equation. Right? You don't know, you don't read, don't need to actually memorize the exact equation for ripple factors, right? We know this one, Q, and then Q is equal to C delta V, then you can directly calculate your capacitor without memorizing the equation. Okay? 21.6 lah, kira lah berapa? 21.6 micro column. Bagikan dengan 0.18. You should get 120 microfarad. Okay? Daripada you kena ingat yang ni. Mana tadi? Kan? Ni semua ni. Equation ni you kena ingat pening juga ni. Ni lah. D over R square root. Saya pun tak ingat. Frankly speaking, I don't memorize this punya equation lah. It's quite tough lah. To memorize all this and then do for final exam. Pening. Okay? Okay, I think that's all for the non-isolated. Any question? For those who yang tak boleh follow tu, you can actually look at the solution lah which is I have already shared with you in the WhatsApp group and I have already upload in the e-learning. Okay, so we take a break maybe 10 minutes. So sekarang 12:03 minit. So we meet again at 12:13. Okay?